also handling number of projects of NITR. And I just hand over the session to Dr. S. Chatterji. He will be giving you an overview of all the renewable energy sources, mainly the hydro and the wind power system and the hybrid systems. Thank you.
Thank you, Shimi. Good morning, viewers, participants at different remote centers, and my own participants here. I wish you a very good morning. Good morning. To start with the session, what Shimi has given me, Dr. Shimi, she has assigned me a task to talk to you about some renewable sources. Of course, renewable sources doesn't necessarily include hydro, but I say that that's also a renewable source. Because hydro has become so popular in our country or in any part of the world that it is no more a renewable source. But definitely water is a renewable source. So I can call it very safely, you can also call it safely, that hydro generation is also a kind of renewable generation. Someone has to operate it, I think. थोड़ा रब कर देंगे क्या पानी पानी नहीं देना पहले इसको ऑन करो ओपन करो अच्छा ओपन करना राइट देन टिक टिक तो करना है ना मेरे को थोड़ा सा अच्छा नहीं लगता मैंने Yes. So my task is to discuss about hydro and wind generation. Now, if I talk of hydro first, bulk of it, as I said in the previous class, also I told you that about 65 to 67% of our total generation is through coal-fed thermal power generation, and rest total about 35% is left, out of which about 20 to 25% is hydro. So the bulk generations are thermal, which is about 65%. Hydro is about 20 to 25%, and rest has all kinds of generation processes, that is nuclear and other non-conventional power generation. So the bulk is thermal and next bulk is hydro. So this is a very, very important aspect of generation of power in India. And if you say the hydro, there are two kinds of hydro. One is the main hydro, and second is small hydro. Now, what do you mean by main hydro, small hydro?
Main hydro is base load or large generation.
Exactly.
Can generate
Exactly.
megawatts more than that.
Yeah, it is the large generation, the bulk generation through hydropower, through hydro as source is known as main hydro generation. And some of it is also generated by small amount of, hydropower, that is known as small hydro. It can further be classified into mini, micro, pico, etc. depending on the size of the hydropower station. Now, it is very obvious when we call this hydro generation, the turbine of a thermal power generation and the turbine of a hydropower generation will be different. Now, can you tell me, by looking at the machine, when you have to generate power, means you have a prime mover and you have an alternator, is it not? The basic principle is that through a prime mover you give rotational power or a potential to the turbine, and the turbine, when the turbine is coupled with the generator alternator, it produces electrical power. That is the basic principle. So you need a prime mover and an alternator. The prime mover is basically known as turbine. So when you have a turbine and an alternator, the coupled system is known as turbo alternator. Turbo alternator unit, या इसको machine भी बोल देते हैं. So turbo alternator machine or turbo alternator unit is the main heart of the system, which feeds the mechanical power to the turbine, to the alternator through turbine, and the alternator produces electrical output. Now the question is, if there are two types of generations, as I said, thermal and hydro, these are the main, of course. So the machines will be same, the principle will be same, but they are different in configuration, they are different in shape, they are different in operation, etc., etc. Can anybody tell me what is the basic difference of a thermal machine and a hydro machine? Can you tell me? Suppose I have shown you one machine is this, is say A, and is B. You have got A, you have got B. One is a machine or a turbo alternator unit meant for hydropower generation. Another is a machine which is meant for thermal power generation. A is the machine which is meant for thermal power generation. B is the machine which is meant for hydropower generation. Can you, looking into it physically, tell that this is a thermal power machine and this is a hydropower machine? Distinguish between A and B. A goes for thermal, B goes for hydro. They are definitely different machines. Principally, they are acting the same way. But what is the physical difference or the structural difference between the two?
Hydro machines are smaller as compared to thermal machines.
Smaller.
Speed is large.
Hydro machines are run by a water surge system.
Run by is an. I am just saying that if you see the construct by look, physical look, A is there, B is there. Can you say that A is a thermal machine, B is a hydropower machine?
By looking at turbines.
By looking at the unit, I am saying. Have you seen a thermal power generator?
No.
So that is the problem. You must visit, go to a thermal power generation and see what is the unit. As I am saying, turbo alternator unit or turbo alternator machine or turbo alternator set. There is a turbine which is coupled with a three-phase alternator. That becomes a turbo alternator machine or a unit. Similarly, go to a hydropower generation, you will find that there is a turbine which has been coupled with an alternator there also, and this is the three-phase alternator, and that becomes a turbo alternator unit for hydropower. Now, let me tell you that you can distinguish between the two by seeing it. Physical construction. One is known as a horizontal machine, and the other is known as a vertical machine. Which is horizontal? Tell me. A is a horizontal, which is meant for thermal, or B is a horizontal?
A is horizontal.
Why?
Hydro turbines are rotated like in vertical direction.
No, it's not that. It's not that. It is the question of a salient force machine and non-salient force machine. One, as he has pointed out clearly, that one machine is at a higher speed, much higher speed. The steam turbine, we call it steam turbine, and the water turbine or hydro turbine. This is steam turbine. The turbine which is used for generation of thermal power generation is known as steam turbine. And the one which is used for hydro is known as water turbine. Now, it is obvious that steam turbine will be much higher speed machine. It is a much higher speed machine, and that has to feed mechanical power to the alternator, that is AC generator of thermal power generation. तो उसमें जो है speed कितनी होती है? Synchronous machine की speed, how much is the synchronous machine speed depending on the number of poles? So what is the maximum speed of a synchronous machine? It is 3000 RPM. So here it is 3000 revolutions per minute, and here it is much lesser, 600 RPM, 700 RPM, or at the most 800, say 500 to 800 RPM. There are different types of turbines, such as cup line turbine, etc., etc., which are much lower speed machines, and they, when have to be coupled with a machine, that will become a non-salient pole machine. तो दोनों में क्या फर्क होगा? यहाँ पर 3000 RPM means how many poles? What is the synchronous speed?
Less 120 FYP. So 2 poles.
Synchronous speed is 2 poles. Yes. (120 F by P) simply. So if you take F as 50 hertz, the P will be minimum number of poles. कितने हो सकते हैं? 2. Why not 1?
It's a combination of north.
It's a combination of north and south pole. It has to be a pole pair. It cannot be less than 2. So minimum कितना हो जाएगा? कितनी हो जाएगी? 2. 2 means the maximum speed what you get, synchronous speed is 3000. Now is it clear? So if it is a high speed machine, means obviously the highest speed is 3000 RPM, and to match that you have to go for a 2-pole machine which is cylindrical in shape, horizontal. मतलब क्या है कि its axial length is more than the diameter. That's why we call it that this machine will be a horizontal machine. आप देख के बता सकते हैं कि ये steam turbine की machine है या steam turbine unit. So it will be horizontal and more length, axial length, lesser diameter. And now come to this speed lower. If you want to have lower speed, means what does it mean? The poles will be greater. Number of poles will be greater. अगर कभी आपने सिंगल फेज इंडक्शन मोटर ये पंखे को खोल के देखा होगा, इसमें नंबर ऑफ पोल्स ज्यादा होते हैं कि नहीं? 2 तो नहीं होते, ज्यादा होते हैं. ये चीजें फंडामेंटल थिंग्स हैं, बट मेनी इलेक्ट्रिकल इंजीनियर्स और मैकेनिकल इंजीनियर्स दे डोंट बॉदर टू सी ऑल दीज थिंग्स. आपको ना नाक कान ये सब खोल के रखना चाहिए. And knowledge is there. You have to see it. You have to verify it. I'll tell you a small story. Once upon a time, long back, Rabindranath Tagore, who used to be a big visionary, उनको किसी स्कूल में chief guest बुलाया. You see, so he was called as a chief guest in a very small school. So he used to say कि no, मुझे क्यों बता रहे हो आप लोग कर लो. I don't normally go. But he was pressurized and he was finally right there. तो वहाँ जाके उन्होंने देखा कि one teacher was teaching the student about different kinds of birds, and she was drawing that this is parrot, this is crow, this is your कबूतर, ये वो दुनिया भर की बना रही थी वो. Instead, then Rabindranath said कि you can go outside and show these birds are there, already there. So why don't you show the students, small kids, that this is parrot, this is crow, and so on. ये ज़्यादा impress करेगा उसको, इनकी memory में आएगा. इसीलिए if you see it, if you observe it, you get more knowledge, and that knowledge is a permanent kind of knowledge in your memory. You will not forget it very easily. That becomes a kind of skill. It is no more a knowledge; it is a skill, and skill is a permanent thing. Knowledge is temporary. अब बहुत कुछ पढ़ते हैं in the form of information. You gather and you refine it, that becomes knowledge. But do you remember all kinds of readings what you have done? You don't. धीरे धीरे पुरानी informations fade away हो जाएंगी. New informations will be fed and you will come to know the new informations. So what happens, if you have this skill, once you have learned it, you will not forget it. जैसे ये लड़की जो है, small lady, she is operating the camera so well. Knowledge नहीं है ये, it is a skill. You are soldering a thing, that's not a knowledge, that's a skill. You are swimming, you are driving a car, you are driving a scooter, cycle, ये सब क्या है? Skill है, knowledge नहीं. कभी have you ever heard that he is a very knowledgeable driver? You will always hear he is a very skilled driver. Skilled driver, he can perform this driving very efficiently and effectively. So observe करिए, नाक कान खोल के रखिए, दिमाग को खोल के रखिए. Many things will enter and you will actually get the knowledge, real kind of knowledge, which is not even knowledge. Higher than that, it becomes a skill. So by seeing, come to the point, by seeing you can now say that if it is a axial length is more, it is a horizontal machine, it will be definitely for a steam turbine, means used in thermal power generation. And it is obviously a high speed machine. The other one, which is smaller speed machine, will be, अगर आपको उसको diameter बढ़ जाए इतना, तो किस तरीके दिखेगा? Vertical दिखेगा. So this is a horizontal machine. And this is a you can by seeing tell that yes, A is a horizontal machine used for thermal power generation, B is a vertical machine used for water. So you have different kinds of systems. Now what is a small hydro? Thermal we have studied a lot. The topic is to say something about hydro generation and wind generation, isn't it? And they are now in the cluster of, what is that cluster? Renewable energy generation. Why you call it renewable? Why renewable? The nomenclature is renewable and non-renewable. Earlier we were using non-renewable fuels like coal, paper, wood, husk, anything which was, it cannot be cycled and it cannot be obtained for a definite long time, is non-renewable. उसको renew नहीं कर सकता. But what is solar? What is solar? Is it renewable or non-renewable?
Renewable.
Why it is renewable?
It is because it is provided by nature.
No. Fossil is also provided by nature.
Nature means they are not.
You see, fossil is also provided by nature, but that is not renewable source. Why solar is a renewable source? Why wind is a renewable source? Why water is also a renewable source? Because there is a cycle wherein you are continuously getting it. There is no storage. No one can say that sun has been stored and उसी से मिलता जा रहा है फिर वो खत्म होता जा रहा है. ऐसा है क्या? आज अगर सूरज उगा है तो कल भी चांसेस है उग जाए अगर बादल नहीं होगा. अगर बादल नहीं होगा तो it will come. So 90% chances are that sun is seen for longer period. It will keep on giving you sun rays, sunshine. Water is a keep on you getting it because it is renewed. हमेशा ये नए तरीके से आपको बनता रहता है. Wind is renewed, solar power is renewed, water is renewed. So they are known as renewable source. But coal, it is not renewing. इसका जो भंडार है उसी में से आप प्राप्त कर रहे हैं. ये भंडार यहाँ है. The other store is here. The other store is here. The other store is here. You are digging. You are trying to find out where is the store. But that store is not increasing. It is limited. So unlimited resource is renewable resource, which is renewed every day. Whereas the coal, the fossil fuel, the wood, the jungle, आप जंगल काट देंगे तो जंगल उगेगा तो नहीं जब तक आप उगाएंगे नहीं उसको. So it will go. That kind of thing. That is why people are saying that go for renewable sources, because the fossil fuel, which is the main source of non-renewable source, that is depleting day by day at a very, very high pace. It deplete होता जा रहा है. इसलिए people are going for non-renewable. So नॉन रिन्यूएबल का एक सबसे बड़ा जो सोर्स है वो है abundance, that is solar. So I'm not touching that in this class. The other one is hydro and wind. So in India also, lot of hydro, lot of wind has started. Another resource क्या है जो non-conventional energy resource है, and that is also a renewable source of energy. Can you tell me what is that? Tidal waves are there. वो उतना नहीं है फिर भी है. Ocean, then magnetohydro, then biomass, biogas. ये भी काफी to some extent a very good renewable sources of energy. Okay, so small hydro is another part of hydro which is being very much tapped at least in 3 states of India. What are those 3 states?
Tamil Nadu.
Tamil Nadu is not small hydro actually, not much. It is the hilly states. Himachal, which is totally hilly, J&K, which is totally hilly, and Uttarakhand is totally hilly. Apart from that, there are certain hills in other parts also. For example, your Kerala has got certain hills. Tamil Nadu was also Ooty and small hills. But these states are fully hill. It is a hilly state. They are hilly states. So they have lot of potential. And if I say that 20 to 25% comes in hydro, out of that, other than that, about 5 to 5%, maybe 5% is small hydro. Small hydro. And small hydro का जो latest figure जो हमें पता है, it is about 4200 megawatts. $4,200 megawatts have already been tapped, but the potential is much higher. Lot of potential is there, and there is a lot of research going on. I have got one PhD scholar who recently defended his theory, his thesis. You must be knowing, Mr. P.P. Sharma. He worked on small hydro. So small hydro has enough scope. You can also work if you want to go for PhD thesis or some other project. You can prepare a project report also. So small hydro has got a lot of scope. In small hydro, what is happening? It depends on absolutely small power generation. So the units are very, very small. They may be grid connected. They may not be grid connected. Means they are sometimes grid connected and sometimes they are isolated units. So grid connected means what? Hydros are all grid connected. Bigger units, megawatts. Your this thing, Bhakra Rangan Dam is there, Rihand is there. So many hydropower stations are there. But small hydro is very few, very small. You will be surprised to know that in Himachal and in J&K there are pico hydropower generations also, as I said. Pico is very, very small. What are they doing? That there is a cluster of village of say 10 families, 10 houses. 10 हाउस वाला एक छोटा सा विलेज है, उसको भी पावर दिया हिमाचल में, J&K में. कैसे दिया? That a small unit is there. Small head is created through the river parts or the springs or water, rains, etc., etc. That head is the energy source. तो होता क्या है कि what is happening in hydropower generation? Thermal power generation कैसे generate करते हैं? You have to know a little bit of it. Steam. No, steam कैसे करते हैं? What is the principle?
Coal.
The resource is coal. Is it pure coal or something else?
No, it is not pure coal. The coal is not pure. It is processed in coal processing unit.
Yeah, coal processing unit करके pulverize वगैरह कर दिया. पहले तो what is the quality? What is the factor or feature on which the quality of coal depends? Can you tell me? किससे आप कहते हैं कि ये good coal है, ये bad coal है? How do you say?
Heating capability. I forgot the word.
Forget the units.
It is the calorific value. CV. CV तो आपने पढ़ा होगा ना physics में. Calorific value is the index of quality of coal. If the CV is high, it is a good quality coal. If the CV is low, its quality is lower. Now, what are the impurities which come in coal and deteriorate It's quality. One is dust, moisture, foreign particles. Because coal it is coming from the earth and it is a pure fossil fuel. So what is happening is these dirts or these impurities which are also there in the earth, boom, it is also getting mixed with it and the coal quality is deteriorated. What are the, by the way, what are the places in India where you get coal?
One is Chandrapur.
Chandrapur is in Maharashtra. Then the biggest Bihar, Bengal, Odisha, right? Jharia, Asansol. Then your what is that?
Eastern region moves.
It is eastern region, and then to some extent, little bit in Maharashtra, little bit in south also. Now, what is happening? Your thermal power generation may be in extreme north. The coal has to come from east. तो क्या करेंगे आप? Wagon में भर के ले जाएंगे, transport होगा. Lot of energy wastage is there. Again, it's a question of energy management. What to do? You have to send the coal there because you cannot have the thermal power generation only in eastern region. You have to have thermal power generation in western region. You have to have it in southern region, in central region, all. So transportation is a very big problem. Although all those problems have been tackled to some extent, and you know that these are the problems, the policymakers know that, everybody. But even then, it is 65% generation is coal. Why? What is the reason? Renewable sources को क्यों छोड़ दिया? इसके ऊपर concentration है. But what is the reason why you are not actually achieving? Why not totally renewable? Why can't you get it? Totally renewable sources, if you can manage, I think that would be definitely better, superior power generation system. But you cannot do it. The question is, you cannot do it. Why?
Source of money.
Resource is in abundance. Sun is in abundance. Water is in abundance.
Technological aspects are not that much sound with respect.
Tell me what economical aspects. I know that solar generation is not an economical criteria. Yes, it is not. Similarly, your wind, similarly hydromagnetic, magneto-hydro, and so on, biogas, biomass. In bulk, you cannot have it. In small amount, you can have it. For research purpose, you can have it. Theoretically, it's okay, but practically, it doesn't stand. What is the reason? The main reason is the technology is not foolproof. The technology what you are using, say PV generation or thermal generation by water heating or solar heating, is not known to us. It is not foolproof. We are still importing the theory and also technology, and also we don't have the technical know-how. वो जब तक efficient नहीं होगा, the process is very, very inefficient. As I said, the PV generation is about 22% or so. The maximum it has gone up to 25%. So 25% में इतना ताम झाम करने के बाद अगर आपको generation मिल गया, it is a very funny thing. That's why people are doing lot of research. It is in the agenda, no doubt, for the next 5-year plans, but it is not coming up that way. Right? So these are the problems. Anyway, so small hydro में उन्होंने क्या किया कि pico hydro किया एक cluster of villages करके उनको power दिया. Then they have micro stations. They have small hydro. Small hydro is in say 1 megawatt or so, but micro and pico are still small. So they can be either grid connected or they can be standalone systems. Now why you go for grid connected systems?
So when grid is not able to go, there standalone systems are used.
Because grid is not available everywhere.
Yes.
It is a remote place. I said the pico किसी JNK के या हिमाचल के remote village में लगा दिया, power तो मिल गया, तो वहां पर तो आपको grid ही available नहीं है, तो कहां से जोड़ेंगे? Second thing, grid connection means you have to have that parallel operation system, and you have to have matching, voltage matching, their frequency matching, phase, etc., which are highly technical, and these problems are not very easily solved. It cannot be addressed very easily, and that's why we better go for isolated systems. But isolated systems are उसमें क्या disadvantage isolated?
Once the supply fails, once the
reliability is the biggest problem. It is the biggest problem. Second thing is, you know, lot of heat is produced. तो वहाँ पर एक dump load use करते हैं, Have you ever heard of it? Have you ever seen? You have not seen a thermal power generation. You have not seen a hydro power generation. Small hydro तो दूर की बात है. You must see. You must go and see all these things. Then only you will be able to appreciate. Small hydro में आपका dump load use किया जाता है. Dump load means the heat what is generated is cooled through the water. And then I asked a question to the वहाँ पर जो थे वो लोग chief engineer. Hey, what are you doing with this wastage of heat? It's a kind of wastage of heat because you have to cool it, so you are using water load, that is dump load. He said कि ये पानी गर्म करके ऐसे गाय भैंसों को नहा देते और कोई यूज नहीं उसका, because you will not be able to produce steam out of that. That is not possible. Only thing is warm. So that kind of thing is there. Again, it is a technical know-how which has failed. So I want to tell you the point that so far as the technology is superb, it is foolproof. You know it. You stand on your own technology. The renewable sources are not very, much in practice. They are either trying to do it. A lot of research is going on, but it will take time. इसीलिए कहते हैं कि जब तक वो नहीं है तब तक आपका थर्मल पावर जनरेशन हाइड्रो मेन तो होता ही रहेगा. होता रहेगा कि नहीं? टू सम एक्सटेंट न्यूक्लियर हो जाएगा. न्यूक्लियर में क्या प्रॉब्लम है? व्हाट इज द प्रॉब्लम?
Radioactive waste.
It is radioactive is best is that's a dangerous thing for health. But main thing is the fuel is not available. Uranium 92 is not available here. So you have to purchase, and that nuclear deal was it's a big deal. So France, we are approaching US also, Russia also. But it is again a politics. It's a problemless thing. So you cannot अचानक डिपेंड करने लगेंगे. न्यूक्लियर जनरेशन is hardly about 1.5 to 2%. But we have been talking of nuclear power generation for ages now. Why? The technology has not come up to its mark. So what is the solution? आपको थर्मल में ही रहना होगा. थर्मल का बिगेस्ट डिसएडवांटेज ये है कि you are eating away your fossil fuel, depleting. After 200 years there will be no fuel. What will you do? तो आपका एक ही इसके पास सोल्यूशन है जो yesterday I deliberately told you that it is the conservation. आपको यूज भी करना है और ऐसे भी यूज करना है कि ये सारा कुछ खत्म हो. तब तक एटलीस्ट करना है जब तक रिन्यूएबल एनर्जी सोर्सेज पे आप बिल्कुल स्टैंड. When the renewable sources will replace this total scenario, then only you can say कि yes, we are now safe and there will be no energy crisis in the world. Now let us see some of this thing, and let us दूसरा जो आपका है wind का क्या है सिनेरियो? What is the scenario? Wind में क्या करते हैं? Now you are very clear that in steam generation, as I was telling you, उसको थोड़ा बता देते हैं कि coal is the resource, no doubt. कोल को आपने पत्थर की तरह मिलता है. उसको पहले वैगन से ले आते हैं, फिर वैगन ट्रिपलर से उसको गिराते हैं, फिर उसको पीसेस में तोड़ते हैं. You break them into pieces. And then you pulverize it to ball mills. Ball mills में उसको घुमा के उसको पीस देते हैं, पाउडर. After that what happens?
Dry up.
पाउडर को यूज करते हैं? No. You mix up some oil with it, which is known as petroleum jelly or oil. Why do you mix oil to it? तो ये लुगदा सा पेस्ट टाइप बन जाता है. That becomes a paste. Otherwise it was a powder. Now it with the some quantity of oil which you get as a petroleum oil, petroleum product, you mix it, it becomes a paste sort of thing. And then in the furnace you throw it by guns at a very high speed. कभी देखा आपने? अब तो देखा ही नहीं. फर्नेस जाके देखिए, उसके अंदर वो फर्नेस है और बॉयलर लगा हुआ. बॉयलर में क्या है? Water. Boiler has water and this furnace is generating heat. So it is a डायरेक्ट हीटिंग बॉयलर और ना लैंकाशायर बॉयलर वगैरह उस टाइप का बॉयलर है. उससे आप हीट जनरेट कर रहे हैं एंड द वाटर व्हिच इज केप्ट इन द बॉयलर इज बीइंग हीटेड अप टू मैक्सिमम टेम्परेचर एंड मैक्सिमम प्रेशर. तो वो स्टीम जनरेट होता है. दैट स्टीम इज नोन एज सुपर सैचुरेटेड स्टीम. उसको ड्राई स्टीम भी बोलते हैं. ड्राई स्टीम मीन्स देयर इज नो मॉइस्चर कंटेंट. इट इज प्योर स्टीम, देयर इज नो मॉइस्चर कंटेंट. वो कब आएगा? सुपर सैचुरेटेड सुपर हीटेड स्टीम बोलते हैं. तो उसके लिए आपको कोल को इतना गुड क्वालिटी होना चाहिए that creates by burning that it creates that much of heat, अदरवाइज तो होगा नहीं। इसीलिए कोल का क्वांटिटी जो है, क्वालिटी जो है, शुड बी वेरी वेरी गुड। वो जो आपका स्टीम बना, that steam is fed to the steam turbine. The turbine rotates at 3000 rpm and it couples with the alternator. The alternator also moves. It's a two-pole machine and electricity is generated. This is the basic principle of coal thermal generation. Of course, here water is treated. Water treatment plant hota hai. It is treated. Why it is treated? pH value maintain करते हैं, so that there is the efficiency should be as good as possible. ठीक है। उसके बाद कोल हैंडलिंग आपका यूनिट होता है, बेल्ट कन्वेयर बेल्ट से ले जाते हैं, और वो लोहा लक्कड़ जो उसको अंदर होता है, those are separated out with the help of coils, right? All those things are done, pulverized, this, that, then finally ये हो गया। Now how do you generate water? Hydro generation? हाइड्रो में यही चीज आप क्या करते हैं, वाटर हेड की एनर्जी को यूज करते हैं। हियर यू आर यूजिंग द स्टीम एनर्जी व्हिच इज अ बाय प्रोडक्ट ऑफ कोल बर्निंग एंड वाटर हीटिंग, इज इट नॉट? एंड हियर in hydropower generation, what you are doing, you are having a dam and the water head is created by falling that water from very big height to the blades of the turbine. तो वो अपने वेट से जो फिरता है वाटर हेड, उसकी वजह से वो टरबाइन को रोटेट करता है। And that is why that turbine cannot have that much speed what a steam turbine can. तो water head की जो एनर्जी है उसको आपने कन्वर्ट किया, this turbine is now coupled to an alternator and it produces electricity. This is, and what is the principle of wind power generation?
The wind is imparted on the blades of the
windmill. Yeah.
And then they rotate. And small alternator is connected to it. So accordingly, electricity is generated.
There are two ways. One is this windmill generation, as you said. It is very popular in states like Maharashtra, in states like Rajasthan, Gujarat. तो गुजरात में भी कोस्टल में बहुत ज्यादा है। But yes, बहुत ज्यादा है. And Rajasthan also. Solar is also very popular in Rajasthan. Solar is also popular in Gujarat. Wind में आपका दो किस्म का है. One is aero generator. Aero generator is a dynamic machine which is double fed induction generator. So induction generator use करते हैं इसके अंदर, और वो जो है generate करता है आपका electricity. For it is DC operated and then it is inverted and converted into AC. इसके लिए आपको wind की पोजीशन, विंड की जो प्रोफाइल है, दैट इज वेरी वेरी इंपॉर्टेंट, एंड इट इज वेरी ऑब्वियस दैट विंड शुड बी देयर। अब कभी तो जैसे इस समय देयर इज नो विंड एट ऑल, इट इज ऑल स्टेशनरी, सो विंड जनरेटर विल फेल हियर। यू गो टू द कोस्टल एरियाज वेयर ऑलवेज देयर इज अ विंड एंड देयर इज अ वेलोसिटी, दैट मिनिमम वेलोसिटी जिसको बोलते हैं विंड वेलोसिटी, दैट हैज टू बी देयर, दैट विल रोटेट द विंडमिल। वन इज दिस, अनदर इज योर aero generator. Aero generator is a special type of generator which is designed so that whenever there is a wind flowing, it will generate electricity accordingly. But the biggest problem is the frequency. If the wind is turbulating, कभी ज्यादा हो रहा है, कभी कम हो रहा है, तो frequency matching will be a problem. So you have to have lot of technology in it to match the frequency and to get the output. So these are basically the three rather renewable energy sources which are now getting popular in India also. One is solar. Solar has come up, PV has come up, but again I will say that the efficiency is not very high. Efficiency is quite poor because the materials are not good. जो आपका क्रिस्टल है वो उतना ज्यादा, उसमें भी बहुत रिसर्च हो रहा है. It is a different kind of materials are being now tried whose efficiency right now they have claimed that it can go up to 40%. अगर 40% हो गया तो फिर it is as good as better than thermal. What is the efficiency of thermal generation? Can you tell me?
Around 40.
It is less than 40%. It is less than 40%. Why? क्यों इतना कम? Where is the loss?
Different losses at different stages.
Where is the biggest loss?
In the fuel itself.
In the machinery, you talk about the machinery.
But when we burn the coal and water gets heated in during
You see, generator is a very highly efficient device. Alternative. Now come to the turbine. Turbine is a mechanical device, and yeah, it has got the maximum loss. The turbine की efficiency, boiler की efficiency, these are the culprits. यहीं पर आपका pitting हो जाता है, efficiency down. On the whole, efficiency will be efficiency of turbine into efficiency of boiler into efficiency of generator into efficiency of transformer. तभी तो power हो गया. तो ट्रांसफार्मर की एफिशिएंसी कितनी है?
Max.
Sir, it is maximum हम देंगे, it will be 98, 99.
99. So it is more than 90%. Generator also is about 85, more than 85%. It is the two culprits are generator, turbine and boiler. Their efficiency is very, very less. So when you multiply, the total efficiency आपकी बहुत कम हो जाएगा. That's why thermal power generation, if it has reached 40%, means it is quite good. There is one power generator, Renewable power plant in UP that has got an efficiency of 45%. Very high. Roper thermal power is also quite high क्योंकि इसके यहाँ static excitation use किया. You know, static excitation that has been used. Clean बहुत है. And Renewable is very, very clean. That's a private. It is Builda's का है वो. Hindalco. So that's why there are few. But mostly, अगर आप देखेंगे, efficiency 36%, 35%, 32%, something like that. So अगर आप PV 40% achieve कर सकते हैं, I would say it is good. तो वो हो रहा है. But it cannot replace the thermal power generation because it is in bulk generation. Now let us see some of the things through our slides. बताओ, slide 1. लाइट्स थोड़ा ऑफ कर देंगे. लाइट ऑफ तो वो करो ना.
क्या हुआ है सर?
इतना ही बढ़ाएगा. ओके.
Next.
But I think the contents are the components of power system, the generation capacity of and demand, the projections, major reasons for power sector ills, hydro, wind and PV power generation. I would like to tell you a little bit of PV also and hybrid power generation. So what is a hybrid power generation? You see, we have been talking of renewable sources of energy, means renewable power generation, is it not? We are talking of renewable. So renewable में देखा लोगों ने कि if one technology is there, it has got certain merits, certain demerits. Now there is another technology, it has got some other merits, some other demerits. There is a third technology which has got other merits and demerits. Now one chap thought, why not we amalgamate all the three technologies and get the merits of all? So that is known as hybrid power. So hybrid power, can you name? It is solar, wind, what cell?
Fuel cells.
Fuel cells, then battery. If you can have all these things, it is known as hybrid power. Next. So power, the building block of economy. We always say the power is the building block of economy. Yesterday I told you about this. Electricity, the most important infrastructure input in the development and growth of economy. I said it is the index and it is the per capita consumption. One in a country is known as a developed country if its per capita income and per capita electricity consumption is high. Then consumption of electricity, important index. Then economic growth rate of 8 to 9% on sustained basis. Now we are claiming right now it is about 7 point something, and 7.7. The maximum is what 8.9% was achieved. It is again the power system which gives you the idea. Otherwise, if you have the power generation, you will go higher and higher. It is obvious. 2/3 of the electricity of electrical generation of the world, yesterday I told you, it is consumed by 1/4 population of the world, and 1/3 of the total electrical is consumed by 3/4 population. This is an irony, very big irony. And unless you improve this ratio, nothing going to happen. Next. Now these are the components of power system. You can very easily see the components are there, the fossils are there, transformer is there, then lines is there, then transform substation is there, so, your transmission lines are there, 415 volt is that battery, second substitution, etc. Next. हल्का सा आ रहा है ये. इसको थोड़ा ऑफ करेंगे.
So last
हाँ उनको कलर ही थोड़ा कॉम्बिनेशन ठीक नहीं किया. आई वुड हैव, मैं बैठा नहीं था ना स्लाइड पर, मैंने उनको बोल दिया था. So he was making. Anyway, generation has thermal power plant, that's solar, hydro power plant, nuclear power plant, diesel power plant, gas power plant, combined cycle power plant. All these are generations. Then solar, tidal, wind, geothermal, biomass, and fuel cells. These are the sources. Out of which your thermal, basically diesel, gas, these are all fossil fuels users. So they are your conventional generation, and rest all are non-renewable sources. Now see, ultimately the paradigm shift will be what? The paradigm shift will be from renewable to non-renewable to renewable. This will be the paradigm shift. And also one more thing. One is the energy efficient devices. अभी वो भी एक बहुत important चीज है. That energy efficient devices अगर आप use करें, so you can do the same task by using lesser energy. For example, your fluorescent lamps, CFLs, LEDs, these are energy efficient devices. Electronic chokes. Then there are CDs now. You see, आप एक ऐसा आ गया है कि cooling chips बोलते हैं उसको. These are semiconductor devices, cooling chips. It is a CD-ROM size. And you can portable type. आप पॉकेट में लेके इसको चले जाइए, उसमें just 220 volt का सप्लाई दीजिए. It can cool as much as a 1 ton AC can cool. इसको बोलते हैं cooling chips. Now these are the inventions. The biggest inventions or research are in the field of material science. You see, ये सारा कुछ material science का देन है. I always plead that the material science should be a very core, important core subject of any engineering. जब तक मटेरियल साइंस आप नहीं जानेंगे, प्रॉपर्टीज नहीं जानेंगे, क्या है सेमीकंडक्टर मटेरियल ही तो है. पहले इनर्ट गैस लगाते थे, ये लगाते थे, ट्यूब्स लगाते थे, अभी आजकल सेमीकंडक्टर्स लगाते हैं. So it is a material, right? So always there has been a research in it. So like that you are improving. Then there is a material called hot semiconductor, a superconductor device. Hot superconductor. Have you heard of it? What is that? Superconductors are those material which will have no resistance at all. That means total conductance. जब resistance ही नहीं हो तो loss भी नहीं होगा. It is known as superconductor. But operation is at very low temperature. बहुत कम, -270 डिग्री केल्विन पर वो काम करता है. तो उसका यूज होना ना होना बराबर है. Whether it exists or not, it doesn't matter to us because we have to work on the room temperature. सब जीरो पे नहीं काम करना है. Now people thought, can we have some amalgamation, some mixture, some compound, some mixing these things, alloys, etc., to have properties of a superconductor at a higher temperature also. Now they have discovered hot superconductor material, which can work not at -273, but it can work at 0 degrees Celsius. तो यहाँ तक उन्होंने पहुँचा दिया. Still research is going on, and there is a company, Google's company in US, which has manufactured transformer and generator, one set each, which is working 100% efficiency at the poles. Poles में sub-zero temperature होता है, वहाँ ये काम करता है. अभी भी रिसर्च चल रहा है, so you can further improve. अगर ऐसा एक दिन आ जाए कि सुपर कंडक्टर आपका रूम टेम्परेचर मिल गया, तो आपका सब प्रॉपर्टी, सारा प्रॉब्लम सॉल्व हो गया इलेक्ट्रिकली. देयर विल बी नो लॉस एट ऑल. ठीक है. सो लाइक दैट यू हैव डिफरेंट काइंड्स ऑफ जनरेशन. नेक्स्ट, ऑल इंडिया इंस्टॉल्ड जनरेशन टोटल इज 15. दिस वाज earlier, I think 1547969. Hydro was this much, nuclear was this much, and rest was this much. It's an old style. Next. Breakup generation. Installed capacity of power plants in India at the end of year 2013 was 2,33,929. But now it is 284. 284 is the latest. The thermal was 68%. The hydro was 17.42. The renewable contributed next 12.39 and nuclear only 2.1%. So you know that nuclear has got, although nuclear technology is a very old technology, it's established technology, but its efficiency is very very less. आजकल हम लोग क्या बोल रहे हैं reactors, कौन से reactors? No, nuclear reactors are there. Fast breed, hybrid reactors. तो उसके अंदर न्यूक्लियर में आपका fission and fusion दो processes होते हैं. There are two processes. One is known as the fission process. The other is fusion. Fission process is the older one जो हमारा चल रहा है. उससे आपका क्या होता है कि when there is a bombardment, then the nuclear is broken into more, and that radiates energy. उस energy को हमने use करना है for heating water, isn't it? Instead of burning coal, I am using this bombardment process. और अगर इसको हम कूल ना करें, इतना ज्यादा एनर्जी आ जाएगा तो क्या कर देगा? न्यूक्लियर आपने पढ़ा है कि न्यूक्लियर? So there is a heavy hydrogen used, which is nothing to cool the process. Heavy hydrogen, heavy water बोलते हैं इसको. Deuterium, D2O, that is heavy water. Heavy water is used for cooling down. That means जो एनर्जी है उसको थोड़ा स्लो डाउन करता है. स्लो चेन रिएक्शन को स्लो कर देता है. स्लो करने से आपकी उतनी एनर्जी नहीं रेडिएट होती जितनी उससे हो सकती है. अगर ऐसा ना करे तो क्या होगा? This is very important step of nuclear generation.
चेन रिएक्शन से कंटिन्यू बढ़ते हैं.
लास्ट हो जाएगा. इट विल बी न्यूक्लियर जनरेशन की जगह ये न्यूक्लियर बॉम्ब हो जाएगा. इट विल बी एन एटम बॉम्ब और न्यूक्लियर बॉम्ब. ब्लास्ट हो जाएगा. दैट्स व्हाई दैट इज वेरी
मॉडरेटर. आई थिंक
मॉडरेटर उसी को बोलते हैं जो स्लो डाउन करता है. इट इज नथिंग बट हेवी वाटर. ओके, नेक्स्ट. Per capita energy consumption in various countries 2009 to 2010. This has given this is a very important slide. Per capita consumption. इसमें इंडिया का स्थान बहुत कम है. इसमें थोड़ा कम दिख रहा है. इंडिया is very less. इंडिया है ही नहीं. इसमें इंडिया का 1000 यूनिट है.
Yes, sir, last. Second last.
Second last is India. So India bar you can see. So now that is the thing. This is the irony. I was telling you that per capita consumption is important. It is not that you have generated 2,84,000 megawatts or 2.284 gigawatts. आजकल गीगावाट से भी ऊपर जा रहा है. टेरावाट्स बोलते हैं. टेरावाट्स है ना. बट व्हाट इज द यूज? इतना ज्यादा पॉपुलेशन है, इतनी अधिक मतलब कंज्यूमर्स है आपके, that many people do not know what is electricity. Still आज के दिन में many people in the country do not know what is electricity and what is its application. जबकि हम ज्यादातर लोग जो शहर में रहते हैं या some elite class we are electrically driven. As I said, I use this word that your every step it goes with the help of electricity. But there are still people who do not know what is electricity and how does it function and what are its operations. तो ये irony है. So per capita consumption is very less. This is very important. Next. India energy needs. India's energy क्या need है देखिए. Energy intensity is energy consumption per unit of GDP. ये चीज आप देखिए. मैंने आपको yesterday I told you that energy consumption और per capita consumption is directly related with GDP. और GDP जो है वो सारे वर्ल्ड मार्केट में बोलता है कि किसका GDP हायर है वो कंट्री एडवांस्ड है. Most places. It is written that energy intensity is energy consumption per unit of GDP. What is the GDP of India right now? What percent?
7%.
It is less than 8%, 7.9 or so. Anyway, high energy intensity points to energy wastage in economy, which can be minimized through efficient use of energy. Yesterday I told you all this. India's energy intensity is 3.7 times of Japan, 1.55 times of USA, 1.4 times of Asia, and 1.5 times the world average. But the per capita consumption आपने देखा. We are even worse than Sri Lanka. I'm telling you. That is the irony. बहुत खराब हालत है. Next. So all India energy and peak deficit इसमें ग्राफ में बताया. Next. Key performance indicators to overcome illness. Illness means there is something called illness in the power this thing. Otherwise, yeah, होगा क्यों? Can you tell me what is the power industry illness? What are those things जिसकी वजह से इतना generation है? Even then, one is the population, of course, but what other factors are there which affect? One is political will. Can you give me an example? Political will का example दे सकते हैं? हर एमपी एमएलए कहता है कि हम यहाँ फ्री में इलेक्ट्रिसिटी दे देंगे, हमारा किसान जो है काम करेगा उसको इलेक्ट्रिसिटी पे नहीं करना. ही बिकम्स अ कैनन है, उसको क्या पता कि इलेक्ट्रिसिटी कैसे जनरेट हो रहा, बट ही विल अनाउंस एंड ही विल डू दिस. एमपी एमएलए मंत्री संतरी सारे लोग ऐसे लोग पंजाब में एवरीवेयर, पंजाब में तो बहुत ज्यादा है, हरियाणा में भी है. तो दिस इज अ पॉलिटिकल विल. व्हाई? या यू मे हैव सर्टेन, थोड़ा सा उनको वो दे दो, छूट दे दो, बट व्हाट इज दिस एनी अमाउंट दे विल यूज, एंड वो कटिया तो अलग से लगाता है. I was there, strange in his, I saw one thing that a person was doing that. I said, what is this? Why are you using? कहते कि डांगरू नु नहलाना जी, पानी गर्म कर रहा. डंगर कहते हैं वो उनको, भैंस को, उसको गर्म पानी से नहलाएगा. This kind of thing. So another thing is, apart from the efficiency of the system, political will, then your equipment, outdated equipment लगा रखा है. Then your technology itself. So these are very, very important. So illness here, energy consumption management, paradigm shift from non-renewable energy to renewable energy source, energy intensity technology, energy efficient technology. This is also very, I told you, energy intensity technology से आप जाइए energy efficient technology. क्या करते हैं आप? अभी जो भी आप यूज करते हैं, चाहे वो हाइड्रो पावर हो, चाहे वो न्यूक्लियर हो, चाहे थर्मल पावर हो, इलेक्ट्रिसिटी व्हेन यू यूज, तो आपका कंजम्पशन बहुत ज्यादा है एज कंपेयर टू योर आउटपुट. जो टास्क है उस टास्क को करने के लिए आपको लेसर एनर्जी में भी हो सकता है, बट यू आर यूजिंग लॉट ऑफ एनर्जी. सो दिस पॉइंट इज वेरी वैलिड. एनर्जी इंटेंसिव टेक्नोलॉजी टू एनर्जी एफिशिएंट टेक्नोलॉजी आपको बदली करनी है. मैंने आपको एनर्जी एफिशिएंट टेक्नोलॉजी का एग्जांपल दिया. CFL, इलेक्ट्रॉनिक चोक्स, एनर्जी एफिशिएंट मोटर्स, योर LEDs. देन जैसे हमने कूलिंग चिप बताया, हॉट सुपर कंडक्टर्स, ये सारी टेक्नोलॉजीज आ रहे हैं. इसको यूज करेंगे तो आप ज्यादा एनर्जी यूज नहीं करेंगे, एनर्जी एफिशिएंटली यूज करेंगे. दैट इज व्हाट इज. So energy crisis I have already explained. Quickly चलो, time नहीं है. Now hydro, wind and PV. So these are, as I said, these are main hydro. You have a dam. You use the energy of the water head या water table बोलते हैं उसको. जितने ऊपर से आप गिराएंगे उतनी ज्यादा एनर्जी आपको मिलेगी. इसके ऊपर, किसके ऊपर गिराएंगे? टर्बाइन ब्लेड. Then you can obtain it from the glaciers. जहां पर ग्लेशियर होगा वहां स्मॉल हाइड्रो का आप यूज कर सकते हैं. ग्लेशियर्स आर इन हाई पीक ऑफ द स्टेट्स, हिली स्टेट्स. नेक्स्ट, नाउ हाइड्रोइलेक्ट्रिक पावर जनरेशन. दिस इज वर्टिकल मशीन. दिस इज ये वर्टिकल. आप कह रहे थे ना कि ऐसे घूमता है, वो ऐसे घूमता क्योंकि वो दिखता ही है वर्टिकल, इसलिए वो ऐसे घूमता है. दिस इज डैम, रिजर्वॉयर, जनरेटर. दिस एवरीथिंग इज नोन टू यू. So this is the way, that is the turbine, and the turbine, as I said, is a low speed machine. So one number of poles are more. It is a your salient pole machine. High number of poles are more, not salient machine. So output like this. Next, major hydropower plants in India. It is in fact the case that major hydropower plants in India are situated in regions of the major rainfall. जहां मेजर रेनफॉल होगा वहीं होगा। पानी आपको चाहिए ना। देयर आर टू थिंग्स, वन इज द रिजर्वायर, वन इज द कैचमेंट एरिया। ये डिफरेंस क्या है दोनों में?
सर कैचमेंट की जब बर्फ पिघलती है तो थोड़ी थोड़ी छोटी छोटी स्क्रीन से आती है, फिर वो देन से कैचमेंट एरिया डिफरेंट है। उसके बाद जब उनको आप इकट्ठा करते हो इन पूल या स्क्रीन को इकट्ठा करते हो,
दैट इज द रिजर्वायर। एंड द रिजर्वायर जैसे डैम बोलते हैं ना, रिहन डैम, वो नदी, दैट इज रिजर्वायर। बट कैचमेंट इज दैट जहां पर पे और भी जगह से पानी आके इकट्ठा हो, एंड देन इट गोज टू द रिवर, एंड रिवर टेल्स यू द रिजर्वायर। रिजर्वायर से फ्लो करा के उसको फिर डैम से गिराते हैं। दिस इज व्हाट इज द मैटर। So these are the areas where you have major hydropower plants. Next, annual rainfall map. कहाँ कितना पानी बरसता है? You see earlier it was Cherrapunji, this was the highest rainfall. अभी चेरापूंजी नहीं रहा। There is another place called, उसका नाम मैं exactly नहीं भूल रहा हूँ उस समय, जो कि बिल्कुल उसके पास ही है थोड़ा, and it has beaten चेरापूंजी। चेरापूंजी से ज्यादा rainfall है, and I've been to चेरापूंजी। मैं चेरापूंजी में गया हूँ, जिसमें साल में हमेशा पानी गिरता रहता है एंड धुंध छाया हुआ रहता है। इट इज द हाईएस्ट रेनफॉल। सो वहाँ नेचुरली रेनफॉल जितना ज्यादा होगा उतनी कैचमेंट आपको ज्यादा होगा, और कैचमेंट जब ज्यादा हुआ तो फॉलोइंग दैट रिजर्वायर। नेक्स्ट, ऑफ कोर्स हाइड्रो इलेक्ट्रिसिटी के क्या क्या एडवांटेजेस हैं? यू नो, द रिक्रिएशनल अपॉर्चुनिटीज, फिशिंग, बोटिंग, then drinking water supply, food control, water for irrigation, etc., etc. Because this is a natural energy and it is in abundance. अगर आप उसने यूटिलाइज, आपने उसको प्रॉपरली यूटिलाइज कर लिया, then it has got very very big advantages, है ना? एंड हाइड्रो का जो अगर वो है कॉस्टिंग देखा जाए तो यूनिट कॉस्ट में भी ये थोड़ा कम ही आता है देन एज कंपेयर टू थर्मल। बट कंस्ट्रक्शन ऑफ डैम इज वेरी वेरी कॉस्टली। मतलब पहले आपको पैसा बहुत ज्यादा खर्च करना पड़ेगा, बाद में the maintenance cost and the operating cost is not much, it's lesser. Next, disadvantages of course, hydroelectric power plants that require the use of dams can really affect the flow of rivers. कई बहुत सारे नेता लोग उसको अपोज करते हैं ना, इकोसिस्टम को वो कर देता है, अनबैलेंसिंग करता है। बट एट द सेम टाइम if you go for it further, that fuming is not there. NOx, COx, SOx, ये सब होते हैं ना fuel gases. NOx means sodium nitrogen gases, then sulfur gases, then carbon monoxide, carbon, ये सारी gases जो है they are very poisonous and they may even cause cancer. इन सबों को इसमें से आप रोक सकते हैं। पहले तो आपने दूसरी तरीके से तो थोड़ा बैकेज कर दिया उन्होंने, बट आगे जो है वो एटमॉस्फेरिक पोल्यूशन इससे कम होगा। नेक्स्ट, इम्पैक्ट्स ऑफ हाइड्रोइलेक्ट्रिक डैम्स, क्या क्या इम्पैक्ट्स है वो दिखाया। नेक्स्ट, सोलर एनर्जी, ऑफ कोर्स सोलर का इसमें इसको स्किप करो। पीवी सेल कहाँ कहाँ पर वो दिखाया। टिपिकल फोटोवोल्टाइक सेल, दिस इज द मेथड। देन नेक्स्ट, एडवांटेजेस ऑफ पीवी। पीवी का क्या एडवांटेज है? मेन पीवी का एडवांटेज क्या है?
Free and available.
So free energy. It's a neat energy, right? It's a very neat energy. Pollution free. That's very neat. Less maintenance cost. Next, disadvantage यही है कि variable energy source with energy production. और इसमें आपने पता नहीं आपने कभी लगाया है कि नहीं, सोलर थर्मल स्टेशन, सोलर जनरेशन हमारा यहाँ लगा हुआ है। इसका एक आइडियल टाइम होता है। The biggest disadvantage is, don't think that it is irradiation of the sun rays that is important. It is not the temperature. Temperature तो 45 डिग्री सेल्सियस हो गया, 50 डिग्री हो गया, तो उस समय जनरेशन क्या होगा? The curve is lesser. The optimum temperature is about 25 डिग्री सेल्सियस। तो अक्टूबर का महीना जो है, अक्टूबर नवंबर, ये महीना सबसे हेल्दी जनरेशन होता है। That is the biggest disadvantage. अभी देखिए, किसी ने बोला कि वहां पर ठंडा कर दो उसको, ठंडा करने में तो आप एनर्जी यूज करेंगे, तो वेयर इज द रिन्यूएबल एनर्जी देन? इफ इट इज रिन्यूएबल एनर्जी, यू डोंट हैव टू यूज अ कूलर और यू डोंट हैव टू यूज दैट, द टेक्नोलॉजी इटसेल्फ हैज इसको मार खाया हुआ। तो वो इंप्रूव करने के रिसर्च चल रहे हैं कि क्रिस्टल को कैसे इंप्रूव किया जाए, मटेरियल को कैसे इंप्रूव किया जाए, उसकी रेडिएशन प्रॉपर्टी को कैसे। अगेन इट इज द मटेरियल साइंस व्हिच कम्स इन पिक्चर। Next. Large scale solar, देखा ही होगा ना panels. Small scale solar. Next. Installed solar power capacity as of 30 September 2000. ये दिया है कहाँ के साथ. Next. Growth trajectory of total solar installed capacity. कैसे देखिए 31/3/2009 में कुछ भी नहीं था, फिर बढ़ते वहाँ चला गया. It is the growth. There is no doubt that this technology is coming up, but there is a limit, and it is going very slowly. Efficiency is less. Next, National Solar Mission. चलो बताओ next. Wind energy. Wind energy का ये दिखाया देखिए windmills जो हमने आपको बताया. Next, इसको बोलते हैं back करो. What is this known as? देखा है कोस्टल एरियाज में होता है, इसको विंड फार्म्स बोलते हैं. एक के बाद लगा हुआ. वाई इतने सारे क्यों लगा दिया? बिकॉज द पोटेंशियल इज वेरी हाई. आपके पास इतना ज्यादा विंड अवेलेबल है, इतना ज्यादा उसका पोटेंशियल है कि एक बहुत बड़ा विंड मिल आप जनरेट नहीं कर सकते. उसकी जगह पर व्हाट वी हैव डन इज वी हैव डन नंबर ऑफ विंड मिल्स एंड दैट इज विंड मिल फार्म. And what you do is you have to get the maximum efficiency out of it. इसमें से कुछ मैंने देखे, I have seen in Gujarat especially that some of them are not rotating, but on the whole it is still generating power. Someone is not rotating, the other one is rotating. Orientation उसका degree ऐसे लगाया हुआ है. Someone is rotating in the same atmosphere and it is producing power. And this is always grid connected. Grid connected. ये wind power generation जो है grid connected. Next. So this is the estimated wind power potential in India. They are shown state-wise. They have shown this in this slide. Okay. Next. खत्म है. I have finished. Advantages, of course. One of the most environmental friendly. Wind is environmentally friendly. Then it has the lowest generation. What is that? I cannot read here. इतना हल्का बना दिया.
Lowest generation development period.
Yeah. When operating cost is low, maintenance is low, maintenance is low. All these advantages. Next. Grid tied wind turbine. ये देखो grid tied कैसे बनाया. This is the system. You can have a grid. You will have a controller. Why you need a controller? Because the wind generator is this, or windmill we call it. Then it goes to the controller. Why do you want to control it?
So wind is intermittent.
Intermittent.
So that is why we are required to
So
maintain.
it is maximum. The problem is of frequency. So have the frequency and then get connected to grid. I have seen in Gujarat all wind grid connected. I don't know whether other states have. Tamil Nadu probably have done it, but Gujarat में बहुत अच्छा किया. Next. So the essential requirements for a wind are the high wind. Farm में क्या चाहिए? High wind, of course. Then adequate land. Suitable terrain must be suitable. Then maintenance, then techno-economic selection of specific turbines, perpendicular prepared layout, etc. Okay. Hybrid power generation, little bit of hybrid. As I said, what are the hybrid systems? Solar. You have solar, you have wind, you have fuel cell, and you have batteries also. So that is the latest, and they are doing a lot of experiments. He is doing a research. She is also doing a research in this.
So in Aurangabad Government College, they have procured that all the equipments and formulated a lab under.
Same thing they have done. You can see here.
They have in total 5 sources have there, including the MSCB, the Maharashtra State Electricity Board supply.
अच्छा वो भी कर दिया.
The all admissions of Maharashtra DT students has been conducted in that place because it's always
okay. Very nice. I think we'll stop here because the time is also over.